Welcome everyone. Let's begin our lesson for today by going over our learning goals and success criteria. First, what are we learning? We're learning how to use logarithms to solve exponential functions, to use logarithmic properties to simplify logarithmic expressions, to compare and contrast mathematical techniques in order to solve complex problems, and to evaluate your options when solving problems in order to solve problems in the simplest and most efficient way possible. How are we learning it? Through the logarithmic properties and critical arguments notes and the logarithmic properties and critical arguments assignment. When can we use this information? To calculate your daily income based on your overall salary, and to look at difficult situations in your life and evaluate your options and opportunities in order to make the best decision for your life. How do you know you learned it? By getting a score of 4 on the logarithmic properties and critical arguments assignment. Now let's take a look at our agenda for today. We will begin by going over our learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the logarithmic properties and critical arguments notes. And then I'll give you time to complete the logarithmic properties and critical arguments assignment on Desmos. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the Reasoning with Irrational Numbers study guide and any incomplete assignments that you may have. Let's take a look now at the logarithmic properties and critical arguments notes. Our notes begin with the learning goals and success criteria. First, what is a logarithm? A logarithm is a mathematical operation that determines how many times a certain number, called the base, is multiplied by itself to reach another number. So it's just another way of doing an exponential function. So this sounds like the similar definition to an exponent. So how do we rewrite logarithms as powers? So we have log base 3 of 9. That's the way we read this, so log base 3 of 9. So in order to simplify this expression, we must rewrite as a power. So really what this means is we're saying 3 to some power, which we don't know, is equal to 9. So how many times do we multiply 3 by itself to get 9? Well, we know we multiply 3 times 3 to get 9, so that's 3 times itself twice. So x then is equal to 2. Now we have log base 2 of 4. So we need to rewrite that as a power. So really this is saying 2 to some power is equal to 4. So we rewrite that as 2 to the x power is equal to 4. Well, we know that 2 times itself twice equals 4, right? Because 2 times 2 is 4. So x in this case would be 2. All right, so let's actually simplify a few of these. So it says log base 3 of 27. So we're going to rewrite that as 3 to the x power is equal to 27. So we don't know what x is yet. So we're saying that 3 times itself a certain number of times equals 27. Well, in this case, we can see that 3 times 3 times 3 equals 27. So that's 3 to the third power. So in this case, x equals 3. Now, log base 2 of 16. So that's really saying 2 to the x power is equal to 16. So how many times do we need to multiply 2 times itself to get 16? So if we go 2 times 2, that's 4. Times 2 is 8. Times 2 is 16. So that was 4 times we multiplied. So x equals 4. Now what if we're using negative power? So in this case we have log base 4 of 1/4. Well, we can see we went from an integer to a fraction. So anytime we do that, that means we have to have a negative power. So what we're really saying here is 4 to the x equals 1/4. So notice we went from an integer to a fraction, so we need to use a negative power. So what we need to look at here is, as long as this is 1, then we're good. We just need to look at this denominator and see 4 to what power equals 4? Well, 4 to the first power equals 4, so we know it's going to be 1. And because it's in the denominator, we're going to take it and make it a negative power. So this would be 4 to the negative first power equals 1/4. So x equals -1. Now here we have log base 1/2 of 4. So we're saying 1/2 to the x power is equal to 4. Well, we're going from a fraction to an integer, so anytime we do that, that means we had to flip it. So we're going to have a negative power. And then we just need to look, 2 to the what power equals 4? Well, 2 to the second power equals 4, so it would be 2. And then we just need to make it negative so that it flips. So we get x equals negative 2. Now, what about fractional powers? So in this case, we have log base 9 of 3. So that's really saying 9 to the x power is equal to 3. Well, notice we start with a bigger number than we end with. So that means that we have to be taking a fractional power of some kind. So 9 to what power equals 3? Well, if we take this is really the square root of 9 is equal to 3. So when we raise it to a power, it's really the 1/2 power. So in this case, x equals 1/2. Now here we have log base 32 of 2. So really that's 32 to the x power is equal to 2. Again, the number we start with is bigger than what we end with. So we know that it's got to be a fractional power of some kind. So 32 to what power equals 2? Well, we can look at it this way. 2 to what power equals 32? So 2 to the second is 4, and then 8, then 16, then 32. So that was 5 times. So we know that 2 to the 5th power is equal to 32. So that means 32 to the 1/5 power equals 2. So x equals 1/5. Now, the logarithmic property of multiplication. So what this says is log base a of b times c. If we can break that up into multiplication, then we can rewrite it in a way that's a little more easy to see. So we have log base a of b times c, and that's equal to log base a of b plus log base a of c. So we can rewrite that as addition. So what does this look like? So let's look at log base 3 of 27. Now we could do this easily and say that 3 to the 3rd power is equal to 27, so it's equal to 3. But let's say we don't know that. Let's say 27 is too big of a number and we need to break it up a little bit. So we can rewrite this as log base 3 of 9 times 3, because 27 is equal to 9 times 3. Then we can rewrite this as log base 3 of 9 plus log base 3 of 3. Now, we can look at this and say 3 to the what power equals 9? Well, we know 3 to the 2nd power equals 9. And 3 to the 1st power equals 3. So that's 2 plus 1, which is 3. Now we can check this by just doing the logarithm. So 3 to the 27th. So that means that 3 to the 3rd power is equal to 27. Which is the same as what we ended up with here. Now, what if we end up with remainders? So we have log base 3 of 18. Well, when we do this, we recognize that 3 doesn't necessarily go directly into 18, right? We can't multiply because 3 times 3 is 9, times 3 is 27. So we can't actually get all the way to 18, but we can get something out of this. So we're going to rewrite this as log base 3 of 9 times 2. So now we can rewrite this as log base 3 of 9 plus log base 3 of 2. And this part we can simplify. So log base 3 of 9 is the same thing as 3 to the x power is equal to 9. Well, we know that 3 to the 2nd power is equal to 9. So we end up with 2 plus log base 3 of 2. We can't simplify this because we can never go from 3 to 2 by multiplying by powers. So we just leave it just like this. Now here we have log base 4 of 48. So we're going to rewrite this as log base 4 of 16 times 3. And you could do 4 and pull that out, and then you would recognize that there was another 4 that you could pull out as well. So you just keep adding stuff in. But the simplest form from in the beginning is to make this log base 4 of 16 times 3. So we can rewrite this as log base 4 of 16 plus log base 4 of 3. Now 4 to what power equals 16? we should notice that 4 to the second power equals 16. So this is really 2 plus log base 4 of 3. We can't simplify this because 3 is not any kind of a power of 4. So we'll just leave it just like this. So 2 plus log base 4 of 3. Now division property. So we could also write these as division. So we could look at it that way, or this especially works well if our part here is a fraction. So we have log base a of b divided by c. And when we rewrite that, we can say that that's also equal to log base a of b minus log base a of c. So let's take a look at how this works. So we have log base 3 of 1/9. And if we remember back to what we did earlier, we should see that this is -2, should be our answer. So let's see if that's true based on the rule we just learned. So we have log base 3 of 1 over 9. So this is really log base 3 of 1 divided by 9, because that's what a fraction says. We can break that up then and say log base 3 of 1 and log base 3 of 9, and we're subtracting those. So now 3 to what power equals 1? Well, we know anything to the 0 power is equal to 1. So 3 to the 0 power equals 1, so that's 0. And then 3 to the second power equals 2. So we end up with 0 minus 2, which is -2. Now, if we were to just do it based on this, the way we learned it originally, we said 3 to some power equals 1/9. So this is 3 to the x power is equal to 1/9. We know that it turned into a fraction, so therefore it's going to be negative. So 3 to what power equals 9? Well, 3 to the second power equals 9. And then we make it negative, so it's -2. So we can check our work and see that these two match. Now how do we do this with remainders? Well, in this case we have log base 3 of 2/3. So we're going to rewrite this as log base 3 of 2 divided by 3. So just like this. Now we can break this up and say log base 3 of 2 minus log base 3 of 3. We can't multiply 3 by itself any number of times to get 2, but we can do it here. We can multiply 3 by itself one time to get 3. So we end up with log base 3 of 2 minus 1. Now this one, log base 5 of 25 over 3. So we can take this and say log base 5 of 25 divided by 3. And then we can break this up. So this is log base 5 of 25 minus log base 5 of 3. Well, this first part, we can look at 5 to what power equals 25? Well, 5 to the second power equals 25. So this is 2. And we can't multiply 5 times itself any number of times to get 3. So we just leave that part as is. So this becomes 2 minus log base 5 of 3. Now there's a video here that shows you how you can check logarithms using Symbolab. So you can go ahead and watch this video. Let's talk now about how to use the logarithmic equation calculator to check your work when dealing with logarithms. So let's say that we were given log base 2 of 8. So log base 2 of 8, and we needed to solve this. Well, we can go ahead and enter that in and click go. And it tells me exactly what the answer is. It says log base 2 of 8 is 3. And it gives me steps to show me exactly how that works. So that's one way you can check just a simple logarithmic equation. Now let's say there was more to it. So let's say it was log base 2 of 8 plus log base 3 of 9. Well, we can go ahead and click go again. And this time it tells me that the answer is 5 because log base 2 of 8 is 3 and log base 3 of 9 is 2. So therefore the answer is 5. We can also do something like this, log base 2 of 32, and click go. We can also do something like this, log base 2 of 40, and click go. And this time it'll tell us, it gives us a decimal answer, but it also will tell us, using the log rule, that it's 3 plus log base 2 of 5. So we can do it that way as well. And this is how you can check your work using the logarithmic equation calculator on Symbaloo.com. Let's talk now about how we can change the base of a logarithm. So we have log base a of b, and let's say we wanted to change the base to c. Well, what we do is we just make it c, so we're going to change our log base to c, and that's equal to log base c of b over log base c of a. So we can change the base anytime we want to anything we want to, as long as we follow this formula. Let's look at an example. So we have log base 3 of 18. Let's say we want to change the log base to 9. The way we do it is we would change this to log base 9 of b, which is 18, over log base 9 of a, which is 3. So it should look something like this, and then we can simplify. Now, let's look at this one. This one says log base 4 of 48. So let's say we want to change it to log base 8. So we would change this to be log base 8 of 48, which is b, over log base 8 of a. So log base 8 of a would be 8 of 4. So we end up with log base 8 of 48 over log base 8 of 4. So this is how we can change the base of any logarithm. Now we're going to be looking at, in this case, Arthur's proof of how he was able to solve this logarithmic expression. And what we're going to do is create an argument of the validity of his proof. So how do we create a critical argument? First thing we do is state how he did it. So we're going to talk about what he did. So what are the steps that Arthur did to get from here all the way down to here? Next thing is determine whether he did it correctly or not. So did Arthur even do this proof correctly? Next thing is state if there's an easier way. So as we look through this, was there a way that Arthur did things that he could have done things even easier? So for today's assignment, you're going to be creating an argument to determine whether Arthur and other people did things in the most efficient way, and did they do things correctly. Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. It's going to pop up with our email accounts. You're going to click on your school email account, and it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click start the activity, and it will take me into the assignment and allow me to begin. So that's how you will log into Desmos using Google. Let's take a look now at the logarithmic properties and critical arguments assignment. Our assignment begins with our learning goals and success criteria. If we scroll down, there's a link here to the Desmos activity. Go ahead and click on that link, and it takes us to a page that looks like this. We'll go ahead and click start the activity. Our activity begins with the learning goals and success criteria. We'll click next, and we're given a proof that Arthur did, and we're supposed to look at it on this slide, and then on the next slide we're going to answer some questions. So it says discuss Arthur's proof, justify each step except the last step. So what did he do? So as he went from here to here to here to here, when he went through each step, what did he do? Now Beatrice thinks Arthur made an error in his reasoning and says that if a is 5, that means that log base 3 of 169 is equal to 5, and that can't be right. And it also doesn't make sense that log base 13 of 243 is equal to 2. You have to decide, is Beatrice right? And if so, why? Arthur then explains back to Beatrice why he thinks he's right, and you're going to decide whether he is correct or not, and if not, what's wrong with his reasoning. So you'll go ahead and answer those questions, and when you're done, you'll go back to your Google form and click next. This will send you to your before you go Go ahead and fill out your before you go and then submit your work on Google Classroom.